Then there are other developments. You might be wondering why the rubber articles are black. When you think of rubber, most of the rubber articles that you come across are black in color. It is because of the combination of carbon black with rubber, a marriage which is unbroken. Rubber itself is the name. The Columbus took it to Europe, but that time it was not known as rubber. It was called caoutchouc, a material that is taken from the weeping tree. Pierce the trunk, white liquid comes out, therefore the locals used to call it caoutchouc. Who named it as rubber? Based on its property. That material had the property to rub the pencil marks on the paper. That's why it is called rubber. It can rub the pencil marks. And that name was given by the inventor of the one who discovered oxygen. Joseph Priestley. He gave the name. Unknowingly, he had done something. He incorporated carbon into rubber. He used it for rubbing the pencil marks and carbon got into it. But many years later, carbon black was deliberately used to improve the properties, to make the rubber article tougher. How it was made? Victoria graduated from horse carriage to motor car. Cars were introduced. The cars had tires, but the tires made up of rubber had an additive put into it which was not carbon black. Therefore the tires were very weak. Every 12 miles or so they had to change the tires. That means your dicky will be full of stepneys, 10 tires at the back, so that because it is a prestige to own a car, and you go 10 miles and then change the tire and again proceed further. So they wanted to find out a substitute which will make tire very tough, and somebody came up with Hancock, if I remember correctly, solid tire, Motic. He introduced carbon black and he found out that the tires become so tough, and today the truck tires can withstand maybe 200,000 kilometers without any damage. 33% of carbon black is added into rubber. It's called a reinforcing filler. It is deliberately, it's a technical material, it's not just carbon. It's a specially made form of carbon called echiniform carbon, which is incorporated into rubber, and the article becomes so tough that the truck tires can withstand all the load, the extra load that Indian drivers put, and then Indian road conditions, it can withstand that. It was a marriage which is unbroken. All these things I told you. Natural polymers, then modified natural polymers, technologies developed without knowing that there is something common. It was left to Hermann Schrödinger and his imagination to say that these technologies, these materials have one thing in common. They are all made up of giant molecules, large molecules, and nobody accepted. And as it happens, any new theory is not accepted even by the scientific community. There is a resistance. Our mind gets creased, and we don't remove that crease very easily. And that's exactly what happened with Hermann Schrödinger when he said that these are giant molecules, large molecules, and that's why they have these properties. And this is the common molecular makeup of rubbers, adhesives, paints, etc. that you come across, plastics. Nobody accepted it. He was in trouble. Till then people were believing that a large molecule means molecular weight 500, 600, not more than that. Organic chemists never believed that there can be a large molecule, larger than what they could feel they could synthesize in the lab. 500, 600. We laugh at it now. We don't even consider that as a molecule. When we compare 1 million, 2 million molecular weight of a polymer, we don't even, it comes in error almost. Till that time, they believed that the interesting properties that these materials have is because of the association. Like the colloid, you come across the term, association theory. They came up with association hypothesis. But he said that simple association will not give these properties. There has to be some chemical linkage between the molecules to give a giant molecule. Now, Schrodinger made this theory in 1920s. He got the Nobel Prize in 1953. See the number of years. Many of the scientists today get the Nobel Prize within 3-4 years. Some are lucky to get it. And this person was lucky to get the Nobel Prize. He was old. 33 years later, he was lucky because Nobel Prize is not given posthumously. He was lucky to survive all these years, and he was not a dead man by the time he received it. If he were dead in 1952, he would have lost the Nobel Prize. But he made that important contribution. See, the scientific community also fails to recognize the importance of the work that is done. He is the father of polymer chemistry. He is the one who said that the basis of polymer chemistry is this, the large molecules, macromolecular hypothesis, which was accepted much, much later. Synthetic substitute, bakelite, this is what I told you. He wanted to find out a substitute for shellac. Here is bakelite, insulation material. Nowadays you don't see those switches with black cap. In older buildings you will see, and that is that bakelite. Rayon, modified cellulose. A contest to find out an alternative for ivory, celluloid came up. A very tough material, but some properties were unwanted, but still it immediately, many of the balls, which billiard balls, were made up of ivory. Ivory became very rare and very costly. They got a material which exactly imitated the properties of ivory, and for many years that was used. Cellulose acetate films, we call celluloid. The film industry is known as celluloid because cellulose was modified to use it. Ivory, the balls you can see here. Now, I have shown another photograph, Eastman Kodak. Kodak company is in trouble, you might have read in the newspaper. A 150-year-old company is in trouble. But at that time, Kodak is the person who used to buy the inventions. And bakelite is the person who patented the material and several others. And Kodak wanted to buy this. When bakelite and others went to him for selling the technology, they were hoping to get it. $25,000 should be all right. But within their heart, they were feeling to get $50,000. 50,000. That's what we do generally. When we try to sell something, this is the market value. But if I get double that, I'll be happy. But they settled the deal for $100,000. And at that time, $100,000, you can imagine, that it was tax-free time. Now we have 30%, 40% tax. And the tax regime was not there. He sold the invention to this man, Kodak is the buyer, for $100,000. And then came a landmark invention. And this invention was done by a young chemist working in a multinational lab. That time itself is multinational in 1920s. And this invention was announced not in the front of corporates, not in front of scientists. It was announced in front of a group of ladies. The hall was full of only ladies. Why that is so? Commercialization already begun. Any invention should lead to, like molecules to money. Direct link had to be established. DuPont announced this invention in front of the ladies because here is a material which can substitute silk, which is tougher than normal materials, as good as steel. If you go by the dimensions of it, it had the strength of steel. And what is the application? Very good. What next? But why in front of ladies? Nylon rope for hanging? Clothes. Why? Good. He is the person who discovered it. It went into making tires. On the tire, if you see, it is written nylon grip, nylon grip. Nylon is the material. It went into tires, substituted cotton, fabric inside. 16 ply rating. If you carefully watch what is written in terms of cotton, if it is replaced by nylon, what is its equivalent? That is written there. It went into making ropes for parachutes. In the World War, it helped a lot. It went into making dresses. But still, answer is not there. Why in front of ladies? This is one of them. Read what is written there. In 1940, 400 million pairs of nylon stockings were sold in how many days?